We're going to take a quick look at sets. A set is a well-defined collection of distinct objects. For example, I can have a set of all the odd integers, or I can have a set of all the students who have completed a first-year linear algebra course. Now, other than using a description, I can specify a set by listing the members or the elements of the set within curly brackets. For example, if I write C equals, open curly bracket, 2, 4, 5, close curly bracket, C will be a set of 3 elements, 2, 4, and 5. And if I write D equals, open curly bracket, open bracket, 2, 4, close bracket, comma, open bracket, -1, 5, close bracket, and then close curly bracket, then D is a set of 2 elements, each of which is a pair of numbers, the first pair being 2, 4, and the second pair being -1, 5. We can use abbreviations if the set that is to be described is large or even infinite. For example, if I write this set here, open curly bracket, 1, 3, 5, 7, dot, 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 99, close curly bracket, this will be the set consisting of the odd integers from 1 up to 99. If I write open curly bracket 4, 8, 12, 16, dot, 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 close curly bracket, this will be an infinite set containing all the positive integer multiples of 4. Another option to specify a set is to use set builder notation. Again, we are going to have the sets specified within curly brackets, but this time there is something more. So in this notation, you will see a colon somewhere in there, and you have the form of the element appearing before the colon. In this case, it's n cubed. And then after the colon is a predicate. For example, I can say that n is an integer where n is at least 1 and at most 100. So what are the elements of this set? Well, it is a set of all n cubed, where n is any integer between 1 and 100 inclusive. So this set will be the cubes of the first 100 positive integers. There are a number of special sets that we see quite often. The first is the empty set, and it is denoted by this symbol. It looks like a 0 with a slash. It's a set with no elements. And the set of natural numbers is denoted by this blackboard bold N. So the set of natural numbers contains 1, 2, 3, and so on. And then Z denotes the set of integers. That is all the natural numbers, 0, and the negations of the natural numbers. Q is the set of rational numbers, and R is a set of real numbers. We'll also look at another set of numbers called the complex numbers. And the set of complex numbers is denoted by C. And finally, we'll look at some set notations. So let A and B be sets. If you put 2 vertical bars around the set, then you are looking at the number of elements in the set. For example, we have here the number of elements of A. And the way to read this is the cardinality of A, or the size of A. So, if A is the set containing the 2 pairs, 1, 2 and 3, 4, then the cardinality of A will be 2. Now, we say 2 sets are equal if and only if they have precisely the same elements. We say that A is a subset of B, written like this. If every element of A is also an element of B. So, for example, if I look at this set here, then it is a subset of the set of natural numbers because each of these is a natural number. If A is an element of the set A, then we write like this. So, if A is a member of A. And if it is not a member of A, we put a slash across this symbol here. So if A is not a member of A. Now form a new set by taking only the elements that are in both A and B. The set can be denoted by this here. Let me write this again. A intersect B. And we can take the union of the two sets. So the union of the two sets is the set that contains elements in either A or B or both. And the set is denoted by this A union B. And if we want to form a set that contains elements only in A but not B, then we form what is called A drop B, and it's written like this. So for example, if A is 1, 2, 3, and B is 2, 3, 4, then A intersect B is just the set containing 2 and 3, because we want to take elements that are common to both sets. A union B would contain all the elements in either A or B or both. And A drop B will be just 1, because 1 is the only element in A that does not appear in B. Now I can also form B drop A, and that would just be 4, because 4 is the only element that appears in B but not A.